Hey everyone, wasn't planning on shooting a video today, but I've got a pretty unique reason making me think about some stuff that I want to talk to y'all about. So first of all, I want to introduce little space dog here, Jules. You might recognize her from the photo on the channel, which I'll probably update with something more official at some point. But anyway, you may notice that my surroundings are a little bit different from last video I took. Last time I was in a canyon up in northern Utah, Provo Canyon, and now I am walking along the trail of the Virgin River in St. George, Utah, and it's quite a bit warmer down here. So St. George is only about 250-ish miles away from Provo, maybe a little bit more than that, but it's significantly lower in elevation. Most people, when they think of Utah, they think of skiing and snow and all that, but St. George, here in the southwestern corner, is actually closer to Las Vegas climate. But this actually got me thinking about temperature on different places we might want to go in the solar system, and specifically about our closest neighbor, the moon. So you would probably think that the biggest determinant of temperature on a planet or a moon or something like that would be distance from its star, the sun, which would be a pretty good assumption. But in the case of the moon, it's basically as far away from the sun as the Earth is, but it has way different climate than what we experience here on Earth. So if you're on like the equator on the moon, in the lunar day, which lasts like 14 Earth days because it's tidally locked with Earth, which means it always has the same side facing us, it gets up to like 250 degrees Fahrenheit. Yeah, so that's freaking hot. And then when it gets to nighttime on the equator, it gets down to like negative 200 degrees Fahrenheit. So well below freezing. And the reason that it does this, despite being basically the same distance away from the sun, which is what heats all our planets and stuff, as Earth is that it doesn't have an atmosphere or oceans the way that Earth does. Turns out that Earth's oceans and its atmosphere actually serve as a pretty good heat sink and like distributor of temperature. And so we get all this energy from the sun that comes through the atmosphere and gets absorbed in the Earth, and it heats us up. But then we have, you know, winds and waves, and the ocean's really deep, and it can contain a lot of, it can absorb a lot of energy. And, you know, if anybody's more of an expert at this stuff, please feel free in the comments. I would love it if you could give like an even better explanation of why this is the case, because I know just enough to be dangerous about this kind of thing. But anyway, the moon has these crazy temperature swings, almost like 500 degrees Fahrenheit difference, which is crazy. And so this is one of the big challenges that we've got to overcome. One of the ways we've been thinking about doing this is going to the poles on the moon. So you have these deep craters around the polar regions, and the way that those are oriented towards the Earth means that they never get any sunlight. And this is absolutely crazy, because you thought the temperature swings between what you see at the equator between lunar day and lunar night were crazy. You actually get all the way down to like below negative 400 degrees Fahrenheit. My understanding is that the coldest temperature reading we've taken anywhere in the solar system is in one of these permanently shadowed regions on the moon. It's, I think it's just like 25 degrees Kelvin above absolute zero, which is the coldest possible temperature. The problem there is we want to get in those permanently shadowed regions because we think that there's ice there. In fact, we know with some certainty that there is H2O there because we have, taken satellite images and been able to analyze that. And there was this really cool mission. We basically took a spacecraft that we were done using and we rammed it into one of these permanently shadowed regions, shot up a plume of stuff, and we had another satellite that was watching this, and it was able to analyze that and find out that there was H2O. So we know there's water there, and we're pretty confident we can find it in these permanently shadowed craters better than we can find at other places, because other places that get exposed to the sun, obviously, getting up to 250 degrees Fahrenheit, that water's gonna boil off if there is any there. It's actually gonna do it a lot sooner than that because the moon doesn't really have an atmosphere. And so the boiling point for water is much lower than what it normally is here on Earth. But anyway, so yeah, I just thought it was pretty interesting. Here we are in February. My last video was in January, and just 250 miles away, roughly, in northern Utah, it was significantly colder. Just made me think about how we have this really weird situation where the moon is getting basically the same amount of energy per unit of space that the Earth is getting, but because it doesn't have the same characteristics of being able to absorb that and move it around, it basically just has these alternating crazy temperature swings. So anyway, I'll be getting into more videos soon. I actually shot a video before this, but wasn't able to get it edited in time, and now it's outdated. So this is the one you get. Last video I was talking about the SpaceX launch test, the Starship SN9, which was amazing, which I'll link to in the description here for you to go and check out. And I was also reminding everybody to watch the Mars rover landing, which has already happened. But super cool thing about that, just yesterday, they held a press conference and released video of the rover that it took while it was going through Mars's atmosphere and then ultimately landing on the surface, which was amazing. We've never seen anything like that before in video. And so I'll link to that as well. Please like and subscribe, share with your friends, try to get the word out, and we'll catch you next time.